Hey, good morning, Drew. Morning, Drew. Not sure if you can hear me. Morning. Can folks hear me?
Yeah, I can hear you.
Hey, hi, Sean.
Did Drew just drop?
Yeah, I think you might be having trouble because that's why I was wondering if anyone could hear me. I didn't hear him say anything.
Gotcha. Yeah.
Sean, I was out for the last few weeks. Did you attend? And do you know what was being discussed?
As I remember, we went through the document and cleaned up most of the remaining comments, patched up a little bit of the like wording here or there. I think
Okay.
that this document is mostly meant to be done, and then we were talking a little about some of the scenario document stuff. I'm a little fuzzy trying to remember where we said we would resume this week, though.
Hey, Sean. Hey, Mita. You're back.
Morning. Morning, Drew. Yeah, I'm back.
So I was a little fuzzy too, Sean. And I'm sorry I'm late. My meeting or my Zoom app on the computer didn't work. So anyway, I
That's
fought
all
it
good.
and won eventually. So I think we want, we need to figure out what we're doing next everywhere, and because we got the documents done, and we need.
Yeah. We were talking
And
about which RAM technologies and things.
yeah, I'll put up the like and yeah, if you don't mind, I'll share the Visio thing I did that shows all the projects, and I can get Visio started. I think I got a I'm dog fooding something, and it did not go well. So get this up.
Hopefully they give you a quick feature toggle.
Yeah, it's not looking pretty. Okay, I'm just gonna have to share it in the browser tab. I can get that to work. Which is ironic because the browser was what was giving me problems a minute ago. Um, let's see. Let's move. I gotta move something. I don't mean to share. Okay. Here we go. All right, can you see what I'm sharing?
Not yet.
Yeah, it says you're sharing, but it's black for me.
Yeah, this is my morning. Huh. I'll try again. Here we go.
Yeah,
I
that
think
worked.
so. This I'm afraid that may be hard to read. I'm going to try to make my screen. Can you read what I've got on the screen? That's it.
Yeah, that's good.
Yeah.
So
Drew, you're silent. At least I can't hear you. I'm not sure if it's
Yeah,
me.
I can't hear you.
okay, I'm back. Sorry, I got kicked out. As I said, I think I need to go roll back my computer. Um,
Oh, that's right.
and sharing didn't work the first. Oh, it did work. Okay.
Yep, it's back.
Okay. Okay. Let's hope this works. So this is me trying to list all the work groups. And Dean mentioned, Dean Liberty mentioned in the email thread on hardware fault management that there was a diagnostic effort that got folded into the debug and RAS recently, so I put it back in there. And that's that group isn't necessarily open. We have these closed groups of smaller groups of companies working, and I don't know. I'm not sure that's the best way to do things. So I'm, asking people not to do that. But what I don't have much say over.
Drew, there are two debug groups.
Uh,
So one is the closed one that you have, I think, next to fleet memory,
yeah,
and then there is an open one.
they got merged.
Oh, they did. When
Yeah,
did that happen?
I don't know, but
Okay, that's good. That's good news. I like
I,
that.
I don't know that they're fully merged.
okay. Rama told me they were merged, that he's in them. So
Yeah, there was some strategy on how they would feed into each other, but
Yeah, that's what I was pushing for when I was at Intel, that this is ridiculous to have two groups doing the same thing. And they both had their own things they wanted to preserve. So I'm very happy to hear they did merge actually, because yeah.
well,
I, I
and
I know the closed one has expanded its membership, but I think the other one, I don't know if they closed it down or not.
that was
But
what was supposed to happen. But
So
and there,
so there are so Sean, there is a GPU systems and GPU RAS. Those are still working in parallel. There is a CPU debug and RAS, and there is a debug and diagnostic. So I think you are talking about GPU RAS and GPU systems diagnostic, or GPU system RAS something. The Hari Ramanath, what is his Hari Rama, whatever, Drew, you know Hari I'm talking about. He is the co-lead for the GPU system one. And I think that is the one that Sean is talking about, is not merged. I
that
was,
one. but he's at Microsoft
I know. He's
and
at Microsoft. I know.
he's helping us with the RAS API. And
Yeah, but in spite of all that, they did launch a separate open GPU systems RAS group. And then Microsoft and I guess AMD, NVIDIA, maybe
no, I
they
don't think that,
started this. Let me finish, right? They started the CPU debug and RAS work group, which they asked Intel to join, but Intel and others had already started or proposed by the time, uh, you know, debug and diagnostic group. And ask from the CLA group was to, close that group and all that. And there was some contention there, but I was hoping that gets resolved. So that's what I'm saying. The CPU ones were totally ripe to merge. GPU ones were not. So probably that's what is Sean talking about.
Oh no, I guess I just wasn't aware if they actually closed the CPU workstream because so we're in the closed group one for the CPU.
Yeah, you were in the closed one, right? So do
Yeah.
you see Marco from and what's the other name? Enrico, they join. Do you see them joining? Because they are the ones who are driving the open one
It's
from
usually
Intel.
John that joins from
John Leung. John Leung is in everywhere. He's like from steering committee point of view. He's not really representing Intel really. He's representing OCP. So
I don't
Intel
I
and
don't think
Intel.
you got it right, Yogesh, with the GPU
What?
stuff. So
What?
the GPU group
Uh-huh.
um there's a GPU management group, not RAS, and they're doing things like
No, yeah, that's what I said, GPU management or something. They're doing something similar. And
no,
Hari is co-lead. John Leung is one of the leads on that.
they're coordinated with us. They're doing things like firmware updates and
Yeah,
then
they are coordinated with GPU RAS. So those two are going to work in parallel,
but
but
they don't overlap in scope either.
they don't. Okay, that's good.
They're
But
not
yeah.
they're not
CPU ones were actually overlapping. The CPU one that Marco and Enrico started, that's overlapping with us. They're
what?
overlapping with CPU RAS, overlapping with everything. So I
Do
don't know
what?
why.
Yeah,
S-
that one was a problem. But
yeah.
the
And
GPU,
I opposed it openly in the hardware management. Like, why you keep approving these groups, which are clearly waste of everyone's time. If they want to do some work, they should do the work in the existing groups, not create their own group and their own mandate and whatnot.
yeah,
This is an industry thing. This is not my personal agenda that, hey, I want to be a lead and I want to tell the world what to do. It doesn't work like that. This
yeah,
is ridiculous.
yeah. I I uh I've had some issues with yeah, I have to be careful. Um,
Well,
but
I don't,
you
I'm
don't
not
have
bitten. I
uh,
haven't bitten my words in the project itself, so I'm not
I,
worried about that.
I I've given strong feedback to some of the people that are doing this, but I
Yeah.
can't do more. So, but
Oh,
anyway, but so all of that's taken care of. Uh, these are the RAS groups, all the groups on that are working on RAS.
No, so then you don't have one of the groups is still right. Either the GPU management one that Hari and John Leung are driving.
Not
You,
working on RAS.
so you're saying that's not overlapping at all. That's why you don't list it.
That's right. It's not a RAS group.
Okay. Okay, then it's fine.
I
and
mean,
there's other semi-redundant ones too. Like there's the impactless update close workstream or some ones like that.
yeah, and I'm not counting those as RAS. That's general management that they're doing things that help RAS, but that's
All right.
general general management stuff. And that's how I look at Harry's group as well. Um, and and so I'm actually meeting with him in the next day or so, because for the RAS API proof of concept, um, he's the Microsoft DMTF representative, and so he's pretty good with redfish, and so we're asking him to help us kind of do a credible, DMTF quality redfish proposal for RAS API. But we'll run it by the RAS API group first. But Carlos and I just wanted someone who knew more about redfish than we did to drive it. But anyway, so these are the groups working on RAS. The the fleet memory, I've got what I think we're working on here. We've got the RAS API, and we're working on the proof of concept and getting the next version of the spec out. The fault management, the proposals are these things, like looking at the PCIe scenarios, and Mita, we may want to come back to your thing some more, and normalizing DPC. These are all proposals that people are talking through, and
Was there some like contention about that scenario that that I talked about before leaving, or?
no, I don't think so. I think I think we want to get it to the point where we can publish it, and we've got to figure out what we do with those scenarios.
Okay.
They're going to be valuable. We need some way to distribute them, and but I'm not sure if we just make our wiki page awesome, or if we actually submit them as official contributions. So we need to think that through, and we may need some help from someone at OCP.
Okay, got it.
But it was certainly not controversial, as far as I could tell. And then the GPU RAS just finished doing debug and crash dumps. So I think they're gonna, there were some updates for these features. I don't know what's next in that group. I don't think we figured it out because we're just finishing the dot. And then the resiliency group, I put what I knew, and I got a little feedback from people like Rama.
This is another closed group, the
Yeah.
resume. Okay.
Yeah, this is SDC. The name is hardware resiliency, but hardware resiliency is like the face, the ability to work correctly in the face of problems. But they've turned resiliency into SDC. So it's a little frustrating with the name, but they're focused. They've had a lot of focus on testing. They're engaging researchers to do research, and Meta's done some pretty cool things, but it's very much like trying to figure things out, because I don't think SDC is understood well enough. So they're actually funding academic research. And the academic research, of course, gets if you get academic people involved, they want to publish. So that part of it's all public. The
Yeah,
academic.
that's a very well funded and very good representation, a deep representation.
Yeah.
In fact, I ran into Bharat yesterday. I
Yeah.
also had a discussion with Devendra from PCI. He was talking about UCI, so that was good. I'm still in San Diego, by the way.
Oh, okay. I wish I was there.
Yeah.
But so anyway, that group is effectively doing things, and they're not super connected to us, but they're people that are common between them, and I don't think that what they're doing is conflicting. And like VLOS is in that, and I think it sounds like you are, or at least were, Yogesh. So what we're gonna do here is probably just take whatever they learn, and if we learn stuff, apply it. And by the way, Yogesh, I'm getting pressured to join that group, but more as a chip expert than a cloud expert. So, because I'm working on Microsoft's first party silicon, so internal silicon. So I don't know, we'll see. I'm not sure I'm gonna join or not, but I'm in enough.
It's great to have visibility, because I think I like their approach. It's very structured, and um, they're trying to come up with software and hardware mechanisms, trying to understand the
Yeah.
problem, model the problem better, and then come up with various layers of how to say it, um, solutions to tackle it.
Oh,
Uh,
and absolutely. No, I'm the only reason I'm
so good to be in that. I almost thought about asking Amber if I should sign CLA for that, but then I, I don't know if really they're very serious in that group, and I didn't want to. I don't know how seriously I would be able to contribute, but yeah, if Microsoft wants you to, and even Sean, if you can peek in that group once in a while, it's good information. Anyone who has Fleet and Silicon, I mean, you have from Google good representation, but even so, I would encourage. It's
Yeah, well,
good.
Baroth is yeah, very very engaged. Yeah. Um, but okay. And then so these are the groups.
What was the name of the last one? Or were we
Uh
still talking about the SDC one?
Yeah, the
just
SDC one, the hardware
Oh, okay.
resiliency, or I think it was server resiliency, because originally they started in the server project. So that's why they came with resiliency, server resiliency, but I don't know if it's still hardware or what. But SDC is
I think
basically,
they were looking for a name. I was in some of the early meetings, and they were looking for a name that wasn't SDC. Um, and they chose resiliency, but I would have preferred something like hardware data integrity or something. But anyway, oh well. Um, I tried to get Amber to change the name, but I just couldn't. At the time I was at Google. Um, so anyway, so I think, like what we've got to figure out is like, given all of these things, there's still plenty of memory stuff to do. Um, and so, there's HBM, there's LP, so we need um, to
so
decide.
in terms of priority, I was thinking further about it. HBM is definitely uh, already there. I mean, it's mature. It's in the enterprise spheres. It's I think looking at 3, or next version is 4, I think. So HBM already has good, well-defined RAS. It's pretty much other than because of topology and I think it has different levels of sparing impact. But other than that, I think the fundamental ECC and all is at par. So HBM would be easy for us to start with. LP is still kind of maturing. It's not there yet. So that would be,
Roy and I were working on it. I mean, your SDC for HBM is lower, but the correctability is not great. And the HBM doesn't have necessarily a good bounded fault story at the moment.
yeah, it's like I said, topology is different. But ECC is good there.
But
Uh,
that's kind of what I was saying is it's good for SDC. It's weak for
Good. How do you have ECC for SDC?
Uh, well, that's what ECC is really for. So if you look at like chip kill, the odds of getting SDC from memory are really low.
No,
And
SDC is something you don't see. ECC sees errors and corrects them.
that's exactly.
There's a fundamental disconnect there.
No, believe me, this is something I'm really strong at, Yogesh. So the point is that you can have memory failures that ECC fails to detect, and that is SDC.
So ECC that's exactly what I was saying. ECC does not correct SDC. When ECC cannot detect it, that's SDC.
So Yogesh, what I'm saying is that if you
No,
look
we
at
are saying the same things. And
is
that's what I said too.
I'm looking at HBM and LP, and HBM has ECC that is good at preventing SDC. It does not have good ECC for protecting against uncorrected errors. LP has bad ECC all around. And
Well, I think we're still going back and forth. Maybe we need to take it offline, but let's just up level. HBM is something that is already ready in the enterprise space. So we can start looking at it and see what kind of logging. Sure, every technology continues to improve, but like you said, and I agree, LP is generally a weak story in terms of reliability, but they are improving it. So
well,
next,
there's a problem there, and that is some of the improvements that and this the vector for LP changed. So in some of the recent JEDEC meetings, um, some of the improvements folks wanted for LP got voted down.
yeah, no, I understand, and that's why I'm saying we should prioritize HBM because we are not in the business of proposing those standards. Once those standards are proposed and adopted by industry, which are more so for HBM, we should be prioritizing HBM over LP. Okay, do
I
you
want to
agree
work
with
with,
that?
well, I want to work with Roy. Roy had
Okay.
a
No,
comment.
I'm not saying don't work with Roy. I'm just saying
Well, let me finish
let's
what I'm saying, Yogesh. I wasn't finished. So I want to work with Roy. Roy had raised some concerns about LP to me, and what we may want to do is do something to align on where the memory technologies are, and then say, well, like we need to kind of baseline people on where the concerns are. And
yeah,
we're not
yeah,
going to fix the concern, uh,
right.
but I think it's fair to raise a pain point
Yeah,
that LP is
no,
on
that's
us not working good.
right thing to do. I asked you to involve me in that effort with Roy like 4 meetings ago. So definitely something to look at. But again,
Well, it hasn't gone anywhere.
JDEC is the one that's going to create the fixes. So, but still, at a high level, superficially talking, I think it looks like HBM may be more ready to take some actionable steps than LP.
Well, and I guess what I'd like to do is I haven't involved you because nothing's happened. But what we need to do is we need to get, Roy had an overview, and if he's able to share some of what he showed me in the meeting, um, we might be able to agree on some priorities and agree on the pain points, and then people, we'll figure out where to divide the work. And some of the work will be in JEDEC, or, we may need to go back to all of our company's JEDEC representatives and go, hey, are you aware of this? What's going on? Why isn't there a better answer coming out?
Can I ask a quick question? Drew, you said something about HBM not being as mature in bounded fault. Like, could you like expand on that a little bit?
Yeah, so HBM memory is generally built with the same mats. Mat is kind of like the so what the memory vendors do is they come up with a mat, that is an array of sense amps and rows and columns, and they optimize the living daylights out of it to get it, packed so that they can cram as many bits into small space as possible. And that's good. That makes memory affordable. But what they do is they lay the mats down in different orders for different memory technologies. And so a lot of the memories will have the same mats underneath. But what we've done with bounded fault is we've constrained the way those things are laid out so that we have very known failure modes. And so when you have a failure in a mat, like a word line or a sense amp, it has fairly well-known implications to the bits that get flipped. And because you have limited, the order, the mapping of failure modes to bit flips, you can design ECC to correct things. And you can do things like make half chip kill. So, like if you look at bounded fault on DDR5, one way you can kind of squint at it and go, hey, that's kind of like half chip kill, where you've bounded failures to really to one DQ, the way it's been implemented. And so by doing that you allow the ECC designer to assume that most failure modes map to one or two DQs and not across all DQs. And so then you can design your ECC to correct that. Because ECC isn't, super magical. It's really a very careful set of assumptions about what's going to fail. And that's how you can design it to work without, having to double the amount of memory you need. So
like for HBM, I mean, are you basically saying that like bounded fault is not like designed from ground up to be as as mature as DDR5? Is that roughly what you were saying?
the ECC and HBM is built in
Okay.
the device, and there's some problems with it. So like there's no standard way to do a retry. There's no, like if you want to scrub memory, HBM memory, you have to watch for a pin on the chip that said, hey, the internal thing in the chip saw a corrected error. And then what you have to do is just write the value back to the chip so that it overwrites the bad value. But the ECC check is in the chip and the retry is outside the chip, and that's just it's like a different decomposition than what happens in DDR. And because of that, it's not clear that the ECC has been optimized for common failure modes.
So this is the ECC on the DRAM, right? Like on the DRAM chips you're talking about, kind of like ECS.
Yeah, yeah, it is ECS. I mean, I even call it that. But the problem with HBM is that HBM is extraordinarily wide. That's how it gets its performance, right? Is by accessing lots of bits at once. And when you do that, you can't have, chip kill ECC because you have one chip, or maybe you have two chips, but they're probably not accessed in parallel. So what you've got to do is we just, I think we could have a discussion about, let's gather data on HBM and let's encourage folks to think about how to build a little bit stronger reliability into it. And we could do a kind of a bounded fault with the internal ECC. So that and basically the amount of redundancy you need with ECC is a function of how many bits you want to detect being flipped.
Mm-hmm.
And so if we put the right amount of redundancy and the right bounded fault width in the part, I'm wondering if we can improve its reliability. I mean, we could, I don't know if it's affordable. You know, that's where the memory vendors have to go. Is this practical or not? And I'm not quite sure. So that's why I want to have these discussions with, you know, what we need to just queue up Roy and say,
Drew, I think those are good and interesting discussions, but I think our focus is more on management, how to collect errors, what to collect. So I don't know if we want to have this full discussion here. Here, I think we should focus on, fault management, which is, how do we enhance the framework and standard to capture errors
I think
from
once in a while,
existing errors. No, I think yeah, I do agree that once in a while and it's all good, but this is a lot bigger and deeper than we want to spend the full bandwidth on. So it's okay to discuss and touch upon it, but I don't think we want to undertake the exercise in this group. We don't have that expertise here, and
well,
even if we do, that's
I'm
not.
not suggesting for an instant that we design the ECC. I'm more suggesting that we um, talk about the goals and what we want from it and what our pain point is. And I agree that someone else will have to work out the details. But like how I don't know where else to do it. Is there a better group? I mean, I can go to the vendors and do it individually, but am I the only one that really wants to do
That's
right?
what JADEC does. That's what JADEC does, right? So JADEC is the place if you're asking me.
Hey, Drew and Yogesh, sorry to interrupt you. Um, I do participate in SPM and LPDR discussions. For HPM, I was listening to, I'm not sure I understand. You're saying there is a multi-bit ECC actually in SPM. SPM is the only memory where we have on-die multi-bit ECC correction.
Yeah, I'm aware of that.
Right.
It's not quite aligned to uh well, let's just say it isn't quite optimal, but I agree there is multi-bit ECC correction.
Right. I mean, we should maybe create a new work stream, I guess, because I understand this work stream really, we started with how do we collect the precise information and then pass back any action, right? Like PPR. Now that was for DDR5. If you want to expand now or move on to new technology, and if it is HPM, then we should definitely start with how we collect the information from HPM, finish that part, and see if there's any changes required in the JDAC also. I mean, and required in the existing design that we need to influence JDAC. Once we've done that, then we should definitely look into now the error handling itself.
I think we should start with the pain points. I mean, like, kind of, we've done that before as well. Start with the basic pain points before going into, error logging requirements, because one is going to inform the other.
Yeah, I mean, obviously the pain point should be discussed first, because if there's no pain point, we don't have any work to do, right?
Right.
And error correction HBM is pretty solid. The problem, I think, what Drew, you were mentioning, right? It's a pretty high stack, like 8 or 12 stack devices, and the load layers heats up. So bit flips, multi-bit flips, bit stack, row failure are so common in HBM that it's just unbelievably.
Yeah, I'm aware of
Right?
some of that from my background. What I want, the other thing I wonder about with HBM though is that the ECS stuff isn't great. Like like you can't get very precise information about bit flips. So we need, like why can't I have an overwrite rule inside the mode registers, and why can't we read out the first error that occurred and clear it inside the chip. So, we can't even gather the data that we need to understand errors. When I've looked at ECC errors, it's vastly less data than we can get with DDR.
Yeah, so ECS is the area which definitely we should work on. I already added something in LPDDR as a JDEC contribution, and I got a lot of pushback. But I'm still pushing on that. But ECS definitely is one area where we can contribute, because and that's what I think is the right thing to do, because the DRAM vendors implement based on the convenience and the right thing, but what is the right thing is not very clear to them also, and we can
Yeah.
provide that.
So that's what we're saying. We want to take this, look at HBM next, talk about what we can and can't collect, create the list of stuff we would put into this API and use and collect if the capabilities were added to HBM, and then push that out as a request for the teams that are working with the JDEC team to
I
standardize.
still just wanted to underscore that we should start with pain points. Yogesh, I know you said that, these may be detailed conversations,
No,
but
no, no. I don't disagree with that part. Always start with why we're doing this. That's the pain point. Then frame the problem. What is there? What is not there? Which is what Sean is saying. And then draft the requirements. And like Anil said, things will come out. Hey, we need this also. Let's drive it to JDEC through our company representatives.
Well,
So
that's what
I agree with everything.
Or so I'm aligned to that. Yeah, that's
Yep.
exactly.
Okay.
And my discussion with ECC was also aligned to that, because there's no way we don't have I agree that we don't have the experts in the meeting, but we can talk about pain points with ECC
right,
and
yeah.
say, hey, we're not getting what we need from this chip.
Fair enough. Fair enough.
One other and kind of unrelated, sorry, one unrelated thing. When we were doing the FMFM spec, there was a TBD thing that we were looking at, which was defining SPD contents. And I don't know if we still want to do that, but
Oh,
if
I
certain,
actually, with a very good you reminded, because I was going to say that too and I forgot. There were things which we said maybe next version, because we are kind of trying to get something out which is easy for right now. So yes, I think maybe that should be one of the things we can do in parallel or do first, to take a look. Okay, this is the version that's done. What is left, right?
Yeah.
Thank you.
Also, as far as problems, I would +1 Anil's issues with temperature and add voltage distribution issues for the deeply stacked HBMs. Both of those are a huge headache for errors.
I think that is the biggest challenge in the industry, that if we can provide some guidance how to optimize the failures due to the high layer of stack, is going to be a huge benefit to the industry.
Yeah, and that we might be able to do by expanding what we're collecting as far as sensor information, and having the vendors help with those models.
Right.
Because they should have structural information.
Just FYI on the LPDDR, LPDDR6 is pretty much locked and loaded. Spec is going to be released by end of the year. That's the hope. It has fairly comprehensive RAS coverage. There's still some areas to improve on. Maybe in one of the meeting I can share.
Yeah, Anil, I was going to ask, would you would you take it upon you to maybe review what's there in LPDDR? So educate the whole group.
Yeah, I mean, right now my focus is LPDDR6.
Yeah,
LPDDR5 is
yeah,
already done.
yeah. No, what's coming? Because I think we
Right.
should be also looking at, when we draft the requirements, we should not there's no point in focusing on DDR3 now, right? So yeah, absolutely agree. What's coming? What's next?
Yeah, in the CPU world, right, the next frontier is LP. DDR6 is going to be still used, but expectation is the volume is not going to be that high.
There's also a transitional set of MRDIMM standards, but they're not all that different from standard DDR.
Right, MRDIMM is also doing bridging the gap. The problem in the industry is that after DDR5, DDR6 is so late. It's open up
Yeah,
a huge
2030.
yeah, open a huge hole. So LP is addressing. I think LP is going to address most of it. That's why LP is becoming so interesting. And MRDIMM, there are a few other technologies being discussed.
Yeah, there's the Franken one too, the LP MRDIMM.
Yeah, LP MRDIMM. Mhm. And in fact, LP is so interesting because one of the challenge with LP is the RAS. And and DRAM vendors are, I mean, who else is here from DRAM vendors? They're very, very eager to improve the RAS. So eagerly listening from the industry what we need. It's a new market for DRAM vendors also, so they are very happy to work on.
Drew, you added a few things. Is like the SPD stuff implicit in any of them?
Also, I don't know how it winds up interacting with the other ones. I don't know if we also want to discuss anything that would be a variant we care about for CXL in this work stream, or if we should leave it to one of the others. Mostly because that adds a bunch of headache around like breast memory, memory spanning multiple cards, yada yada yada. And machines with multiple generations of memory simultaneously. We made our box really big though. Is this just we're gonna prioritize this, or
Drew, if you're speaking, we haven't been able to hear for a while, but not sure if you have.
Oh, yeah, somehow I got muted. I don't know. I
oh,
didn't,
I thought you were just silently doing things we were saying.
no, well,
I thought you were brooding.
no, I wasn't brooding. I was responding too. So thank you for saying something. No, I don't know how I got muted because I didn't hit the mute button, at least on purpose. But I think that these are just like things we're going to bring up, right? And like I don't know the answer. So we'll discuss them and find a home for them, or decide that we don't need to talk about them, or decide to dig into them. So
Yeah, it's a great list to kind of like whittle down from.
yeah, this is more just brainstorming. So there are no wrong answers, and we'll whittle it down later. So I think this is a pretty good list. But I'm hoping I can get Roy to show the kind of the overview of the different memory technologies that he showed me and where he thought they were. If we can do that, that will also expose some pain points and be useful. And some of this will be, requirements that we want to handle other places, and then we'll have to figure out what we have to handle locally. So that'll just be part of the process.
By the way, Roy also shared a paper that he is about to publish, which I really liked. Drew, you probably know about it because it was a paper about collaboration with Microsoft. I don't know if he's at some point gonna share it with
Oh
the
yeah, yeah. That definitely. We should ask if he will review.
yeah. It was one of my favorite holiday readings.
Okay, awesome. Yeah. Well, and the reason I keep coming back to Roy is that I just had one meeting with Roy where we were talking about something else, but he gave me a earful of things that I thought of thoughts and ideas that he had. So I just want to circle back and get him to. It looked he had put some thought into it, so I think we need to hear him out. But sounds good. Okay. Uh, Good. Well, this is a good list. So I think maybe next week and the only reason I'm doing it all on one page is just it kind of shows that we have breadth and we're collaborating. If there's I'm sure there's a better way to do it, but um, if and I can send this picture out afterwards. Um, but I think just I was trying to have a big picture that showed how all the groups are working on things and how we're coordinating. And part of it was because we want to make sure the closed groups are aware that we have a framework of things that we're doing and that they need to stay, tied into our framework.
Hmm.
So anyway, okay. Well, thank you. That was helpful. So I'll send this out. I'll also, or Yogesh, do you ever talk to Roy, or do you want me to reach out to him? And see if he'll present his paper and the other stuff. Oh, I'm sorry. I heard a few syllables of that, but I think you were broken.
Oh,
Was
thank you. No, I think it seemed like you were already talking to him. So continue and decide when it here. Then
okay. I'll ping him and just say, hey, can you present something and see what he's willing to do. Cool. Okay. Well, good. So we had to figure that out, and it's kind of interesting that we don't have memory suppliers here that I can tell, but that may end up being useful, and we can uh, uh, collect other pain points. I'll send this out, and please come back with other thoughts if you have them.
so do stuff in JEDEC, but I was in touch with Jordan Chin. Dell did create some of the modules, and they have a pretty good analysis on thermals and everything else. But I'll talk to Kevin. He is popped in here a couple of times at least, but not lately. So I'll ask around him, and Jordan, he's with Rambus now. So
So I'm sorry, part of that broke up. You're going to talk to Evan, or was you mentioned?
No. I was continuing your thought about having the DIM vendors and maybe HBM module vendors, LP module vendors, sorry, not HBM. I know Dell has done a lot of analysis and work, so maybe we are able to ask someone at Dell to help us with that. Kevin Cross used to join here, and also Jordan Chin, who is with Rambus now. So yeah, I'll find out.
Sounds
Yeah.
great. Yeah, sorry, you were breaking up, so that's why I was confused.
Yeah, I don't know. I don't have my usual setup, so something new about this. So sorry about that.
Okay, so well, that sounds great. And so there'll be a little bit of storming and norming as we figure out what's next, but that's great. I think we have a good list to go over.
In the meantime, we can, while we are figuring out, we can, just next meeting, we can start with what is left in
Well,
this DDR stack. What
well,
else we need to do, right?
yeah, and I didn't finish my scenario either. Like I'd like to
Oh
get
yeah, there's that. Sure.
the memory scenario done as well. So
Mhm.
yeah, so we have stuff to cover, but I'm just trying to my fear is the reason I didn't do the scenario today is that um my fear is that some of these things will have lead times, and so the sooner we get started on the lead times, like let's get started on the things that have long lead times, and then we can fill the gap in
Yeah.
between meeting the lead
Mhm.
time with the
Mhm.
scenario.
Sure.
Okay.
All right then. Right on time. Thank you, everyone.
Yep. Thank you.
Thanks.
Oh, and by the way, Yogesh, sorry, one last thing. The I did upload the final draft, like final from all the steering committee feedback, and the steering committee feedback on this spec was pretty minimal,
Right.
which was good. I mean, but like McAllison read it. He's incredible. I don't know how he reads everything, but
Mhm.
so anyway, as far as I can tell, the poison one they've told me is going to be published this week. But I think our doc should be published this week also.
Awesome. Thank you, Drew.
I don't know. We'll see. Okay. Uh, okay. Well, that's all I know. But I just wanted to mention that we are making some progress.
And did you tell everyone that we did talk about FMFM at RTC?
No, I didn't. Yeah, and I have no idea what happened there. I mean, I just talked and walked away because I did it remotely. So folks wondering, Yogesh and I had a presentation, and I was like sitting at my desk here at home.
At what, sorry, at what did we talk about FMFM?
Initial test conference. So we talked about various initiatives that we're doing in FMFM. And
Sorry, couldn't hear that, but
Yeah,
it's really bad. So yeah, let me try to repeat it. Can you hear me now?
Yeah.
yeah.
Okay. We were presenting at International Test Conference that is taking place in San Diego. I am there in person. Drew presented from his home lab. He talked about the OCP initiatives, including FMFM there.
Oh, wow. Nice.
So I think it says contributor upload final document. I thought I'd done this. Let's see. Yeah, okay. I did. I submitted one file request ready for review. Can you see what I'm sharing?
Hmm.
So this is the dashboard. And so my flows, I guess it's done. I mean, like I think I've done everything. I just never know. It says upload final document. Okay, good. Upload final document for publishing to the database. I'm sorry, I don't mean to ignore you. Yogesh, I was just trying to be, oh crap, did it happen? So I did submit the
Hey,
file.
ignore me by all means. You're doing all the work here. I'm happy to be ignored this way. You did a lot of work. Thank you.
So I think like the way it works is that you do the upload of the final document and the steering committee feedback. And so like the poison doc in the review, thank you for submitting your final document. We'll get this published this week. So I know about poison from a message from Alicia. I can ping Alicia if it doesn't move forward, but I think we're done. I just was trying to confirm. Okay, well, I didn't mean to keep you all. I just thought, you know, I'll show you, hey, look, we're on track, but I just never know with this dashboard. Anyway, I'll check in with Alicia.
Okay, thank you all.
Okay,
Thanks,
thank you.
Drew. Bye.
Thank you.
Raquel,
Bye.